Well, hi everyone, this is Bob the Science Guy. You may recall a conversation I had with this particular individual when I first came on TikTok. And one of the things that we talked about just before he kicked me off his show was that we could measure the radius of the Earth using the odometer of our car. And that was just absolutely mind-blowing to him. So I got to thinking, I haven't actually shown you how to do that. Let's go ahead and do it. Now this is a very simple demonstration of a measurement of the radius of the Earth. Now in order for you to better understand what I'm talking about, let me go over a concept in trigonometry. Now if you have a circle of radius r, there is going to be a distance along the circumference of that circle that has the same length as the radius itself. That's called a radian. Now as you may recall, the circumference formula for a circle is 2 pi radius. And since the radius and the radian are the same length, we can say this is 2 pi radians. Now we're used to talking about circles in matters of degree. However, we can also talk about circles by radians. Well, what's a radian compared to a degree? Well, 1 radian equals 360 degrees divided by 2 pi. Sometimes you'll see this listed as 180 degrees by pi. Here's the trigonometric bottom line. 1 radian equals 57.3 degrees. If you take any circle of any radius and take out a 57.3 degree section of that, this portion of the circumference will equal the radius. Now the key concept here is that you don't need to know the radius of the Earth. You just need to know how many degrees you have traveled across the surface of the Earth. And then you can calculate what 1 radian would be. And once you know what 1 radian is, you know the radius of the sphere. Now let's look at a couple of examples of this, real-life examples that you can do yourself. This is one of those measurements that anybody can do with literally no equipment. There are 3 things that you need to have. 1, you need to find a north-south road that is at least probably 50 or 60 miles long. Second of all, you need to get the exact coordinates of both the start and the end of that road. And you get that from your phone, from your GPS. You just need the exact latitude and longitude of each end. And then third, go out and drive it. Keep track of your odometer. Use your odometer to figure out how far it is from the starting point to the end point. Now this is over in Professor Nixie's neck of the woods. This is Denver, Colorado, and just north of Denver there's a little town called Wellington. Now if you measure the distance along a straight north-south road between Denver and Wellington, you find that it has a map length of about 66.4 miles. If you put it into Google Maps and say I want to drive between these two locations, it'll say 70 miles. However, I think that involves going into town a little bit too, rather than going to the intersection. So let's have a look at the math behind all of this. Now right here you'll see the coordinates of Wellington. This is 40.7051 degrees north and it's 105.001 degrees west. That's what the negative means. Now the point in Denver that we started was 39.7402 and its longitude is 104.9896. As you see, these longitudes are very close to each other. So it's 70 miles by drive and 66.4 miles as the crow flies. The difference in latitude between these two locations is 0.9649 degrees. Well, how do we figure this out? What we do is we divide 1 radian, which is 57.3 degrees, by the change in latitude and then multiply it by the distance that we drove. So, if the distance is truly 70 miles, the radius of the Earth is 4,156.9 miles. However, if you look at the actual distance between those 2 points of 66 miles, we calculate a radius of 3943 miles. Now the accepted radius on average is about 3959 miles. Now, does this only work in Denver? Well, turns out no. In South America there's a little town called Atalaia, and that's in Argentina. And here are the coordinates. It's 38.9687 degrees south, 64.0731 degrees west. So here is La Adela, and if you look at the north end of this road, there's a little bend in it. This is a very straight road that goes due north. But right up here at the end, there's a little bend. Let me show you that. So here's the north end of the road. You see this sharp turn to the right. I stopped the measurement at that turn. So let's go ahead and find out the data on it. Here's the coordinates of the southern end of the route. Here's the coordinates of the northern end of the route. The difference in latitude is 1.156 degrees, and the distance is 79.6 miles. Now, we did the same calculation that we did up in Denver. The radius this time comes out to 3945.57 miles. It's less than a 0.3% error. Now, let's look at one more place. One was up around 39 degrees north, one's down around 39 degrees south. Let's look at the equator. So here are two locations in Brazil. You can look them up if you wish. One is Dom Elisen, and the coordinate is 4.2929 degrees south and 47.557 west. Likewise, here are the coordinates for São Miguel, Brazil, which is due south of it. Now the distance between those 2 points is 183.63 miles, and the change in latitude is 2.6721 degrees. Let's go ahead and do our math. Same math. We have 1 radian, the number of degrees changed, times the distance. Radius comes out to 3938 miles. That actually surprised me. I thought it might be just a little bit more. Probably rounding errors. And that's that. So using a little more than your car's odometer and a little knowledge of trigonometry, you can easily calculate the radius of the Earth yourself using equipment that you already own. You have access to a vehicle. You have access to a GPS device. You can use a calculator. Now, one thing that's very important to note with this is all 3 locations that we went, different locations on Earth, same hemisphere, but different locations, all came back to exactly the same radius. If you do this anywhere in the world, you will come back to approximately the same radius. Why do you think that is? This is Bob the Science Guy. Thanks for stopping by. Make sure you give me a follow if you like this sort of content, because I'm going to be putting out quite a bit of it this week. Take care, guys.